Hi there. Thanks for joining us on Space Nuts Q&A edition. This is where the audience sets the agenda and we answer the questions to the best of our ability, which is not much ability at all, but we'll do it anyway. Coming up, questions about light pollution, a space parasol to protect Earth. Interesting. Also, salvage rights in space and radio waves. That's all coming up on Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And he's back again, Professor Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. Jonti, hi there.
Good afternoon. How are you going?
I am well. Want to get straight into it?
Yeah, let's dive on in.
Okay, question time. And our first question comes from Mark. He says, hello, I have a question about light pollution. I live in Connecticut and the light pollution is not as bad as New York City, but it is enough. I'm planning a trek to Montana this summer just to see the night sky. My question is, if I was standing in my yard and there was a sudden EMP burst and all the electric lights went out, how long would it take for me to be able to see the night sky in Connecticut as clear and as beautiful as Point Nemo? I understand light speed is fast, but how fast would it be to clear the view? I've just recently discovered your podcast. I learned something new with each one. Please keep up the outstanding work. I look forward to every new episode. Sincerely, Mark Bookbinder. Thank you, Mark. That's a lovely comment. We don't get many nice comments. Everyone's usually sticking the knife in. No, I'm not kidding. Most people are terrific. Although we get the occasional jibe, but that goes with the territory. Yeah, look, I had to think about this one, and I would suggest, I don't want to steal your thunder, Jonti, because I know you've done your homework, but I would suggest that it would be fairly instantaneous because the amount of light coming down would be the same. It's just that it's disturbed by the light we're sending up. So when that light we are creating suddenly disappeared, surely the effect would be an instant view of what's really happening up there.
Effectively, I think that's pretty much it. There's a few things there's a few things that fall into that, and that's a really good kind of executive summary type level. So the reason that light pollution is a problem for you seeing the night sky in all its wonder is you're basically increasing the brightness of the whole sky by an artificial amount, which washes out the fine detail of the darker, the fainter stuff. So the brighter your light pollution levels are, the brighter the sky is. And so the fewer faint objects you can see. And the more you brighten that, the less you'll see. If you turn all the lights off at once, the sky will almost instantaneously become as dark as it could possibly be. And then what's working against you is the adaptation of your eye. So we have this thing called dark adaptation, and it's how our eye adjusts and responds to low light levels to allow us to function in those light levels effectively. And you get the bulk of your dark adaptation within about the first 5 minutes, but your eyes continue adapting and getting better and better at seeing in the dark over about a 45-minute period. So you have to be out under the night sky and avoid looking at any sources of bright light for about 45 minutes before you're as adapted as you can be and you can get the best possible view you can get. Now, what would happen is if you were out and about in your sadly light-polluted skies in Connecticut, you are not very well dark adapted because the sky is very bright. So your clock would have to start ticking from the point the lights went out. So I would hope that the lights stayed out for at least an hour for you to give you the best possible view. But even then, you might not get the best view of the night sky you could anywhere on Earth because you then run into the issues of the Earth's atmosphere. Now, I regularly go out to the wonderful Lady Elliot Island on the Barrier Reef where there's effectively no light pollution at all. And the sky is dark enough that, for example, I can see the Triangulum galaxy, which is fainter than Andromeda. I can see pretty much every time I go out there, there's a darker light. And I lead guests in some stargazing there and tell them how awesome the sky is. But I make the point that if they were to go to the centre of Australia, to somewhere like Uluru, or out into the Nullarbor Desert, they'd actually see a better sky there than we see at Lady Elliot. Because at Lady Elliot, you have a limitation that you're surrounded by very humid, very turbulent air because of the energy from the ocean stirring the air up. And so different locations on the Earth offer different clarity of the night sky. So what I'd suggest is that from Connecticut, I've got the light pollution map up here, which is lightpollutionmap.info for people who want to look and weep at how bad the skies are from their location and plan their dark sky holidays. That's a really nice little website. You're relatively coastal, and so therefore your air's going to be quite humid and turbulent. And I would suggest if you turned all the lights on the Earth off, that you would have an experience probably comparable to what we get in coastal Australia. Whereas if you went deep into the inland and you got a really dark sky, it'd be better. If you then went to higher ground, like perhaps in Arizona, which I understand is a quite high altitude desert, if you're at higher altitude, there is less air. So therefore there is less muck and you get a better sky.
Yeah.
But that's balanced by the fact that if you're at high enough altitude, you're not getting as much oxygen and you don't see as effectively. So I've had stories from colleagues of mine who've been up to the great observatories in the Andes in Chile and also up in Hawaii, who've gone out on a night and they've initially been quite disappointed that they didn't see a sky quite as spectacular as they thought they would do. And people on Hawaii actually will often have a little bowl of oxygen and have an inhale to increase their blood oxygen levels, to increase the response of their eyes to counter the thinner atmosphere, and then they get a really spectacular view.
Wow.
So, like most questions, there's a very simple answer, which is as soon as the light goes out, you'll get a really good view. But that view will get better as your eyes adjust to the darkness, but how good a view you get is not just dependent on the light pollution. You'll start to bring in other effects. And my hope would be that the EMP burst and the end of all street lighting would happen at new moon rather than full moon. Because if you've got a full moon in the sky, all those effects of humidity and dust are exacerbated. And even with all the lights turned off, the night sky at full moon is a bit disappointing. You know, if I could do one astronomical thing as a kind of great celestial dictator, I'd get rid of the moon.
Yeah.
It's just a pain in the backside. It's always in the way when I want to take photos and stops me seeing the more interesting things. It's like, I'll lock it into a kind of one-to-one orbit with the Earth's orbit around the sun, so we only ever see it as a very thin crescent. So it can be beautiful in the early evening, then bugger off so I can see the prettier things.
I can tell you why that's a problem. It's because everybody likes mooning in photos.
Absolutely.
Oh, dear. I just thought about the physical effect of the light being turned off. But yeah, I didn't consider the atmosphere or the location or your eyes adjusting. I just had a look at that light pollution map website, and I've honed in on Dubbo where I am. Now, if I just look at the nearest towns, I'd have to go just a bit over 20 kilometres out of town to get to a dark sky area, which is not too bad. But if you're in Sydney, forget it. You're going to have to drive a few hours.
But do yourself a favor and zoom out and then look at the eastern half of the US. Or look at Eastern Asia, and you'll see why we are so left.
Gosh.
Yeah. That's why astrotourism's such a growing thing for us here in Australia, because even in the big cities, you know, I moved to Sydney in 2010 and lived very briefly in a hotel right in the centre of Sydney, in the most light polluted part. But I could still see the Milky Way from the roof of the hotel.
Yeah.
Because our skies are so good. There's a couple of factors there. One is that Sydney itself puts out a lot of light, but there's not much else around. So if you're looking away from Sydney over towards the ocean, you're looking towards darker skies. So that helps. But the other thing is, and this ties into why we get sunburnt so easily in Australia, the air is just clearer. So I moved to Australia and everybody said, you're going to get burnt by the sun and it's awful. And my first thought was, that's the ozone hole. Because I thought Australia was further south, because I'm used to our corrupted maps that show the southern hemisphere wrong, and so Australia looks like it's near Antarctica, and Australia is actually near the equator.
It is.
So it's not the ozone hole at all. But I talked to some people, it's actually due to the fact that the air in Australia has a much lower amount of particulates in than any other continent, to do with what's on the interior of the continent, to do with the fact there's less pollution. So that means there's less to scatter the solar UV, which is why we get higher UV indices and therefore more sunburn. So it's a quirk of geography rather than just lots of clear skies, which mean we get UV indices up to 13 or 14 on a hot summer's day, and basically you fry to a crisp very, very quickly. What that means for astronomy, though, is that for a given place with a given amount of lighting, we actually get a better sky than we would do in other places because there's less to scatter that light. So that same amount of lighting has a slightly lower impact. One other story that ties into this that I always remember, one of the big hurricanes, probably 20 or 30 years ago, knocked out the power across great swathes of, I think it was Florida. And many people saw the Milky Way for the very first time in their lives, and there was panic. People were actually calling up their local police.
Oh, I remember this.
Because they thought that the aliens were coming because the sky looked so weird and unusual because there were all these bright points of light in it and this weird milky glow going across the sky.
Yeah.
And we laughed, but it tells you just how decoupled people are from something that's been so wonderfully culturally significant for all of our history. It's so important to the traditional owners of the land here in Australia, but also all around the world, who have this deep and intimate connection to the night sky. And an event like that really drills home the damage we've done and how we've removed this. And I'm always amazed at the reluctance of people in kind of groups on social media to accept that light pollution is a problem, because I can lay odds that the same problem who say, don't be grumpy, we need our lights at night to see, would be really, really unpleasantly happy if we had the same level of noise pollution. If they had their neighbours kicking out AC/DC at 1 a.m. in the morning, they'd be kicking off to the council.
Yeah.
And it seems that we view light pollution a lot less seriously than we view sound pollution or other forms of pollution. And that's changing a bit. But there's also an energy side of it. I mean, this is a bit that always makes my head hurt, is if you're throwing 30% of your light up into the sky, you're wasting 30% of your electricity and you're therefore just burning money. And yeah, I'm sure the energy companies love that because they get bigger profits, but it doesn't seem a very efficient way to do things.
No, and when you look at the map, eastern United States, basically all the United States, but particularly the eastern half, Western Europe, East Asia, and even the eastern half of South America, pretty well just light pollution central. Yeah, but you look at Central Australia and parts of North Africa, Greenland, although it's an ice cap, so it makes it a bit difficult. But even the big areas around Russia and Siberia, complete darkness, which is very good place to go if you, well, probably not Russia at the moment, but good places to go to look at the sky. And in terms of air quality, they did a test a few years ago and found that the most pure air in the world crosses Tasmania in southern Australia.
It sounds about right, but it is why there is a growing interest in astrotourism in Australia. I've spoken to a few people about this in the last 12 months, where local councils and different commercial groups are looking at adding astronomy activities to their offerings, because they're aware that for people coming in from a lot of our places that source tourists to Australia, these are people who've never seen the Milky Way, who've never seen the night sky properly. And to them, it's this kind of romantic ideal that they could have a night lying under the stars and see the Milky Way above them. And that's just a reality here. I step outside in my backyard and I see the Milky Way. And that makes it a really big tourist draw, and people are cottoning on to that. And that will then be extra ammunition for us improving lighting laws in Australia, because there's an interest beyond just astronomers. There's a commercial interest to drive that. So I think it's a real positive thing. And we'll see more of it. But in the meantime, roll on the EMP bus.
Yes, indeed. Thanks for the question, Mark. See what you've started? Good to hear from you.
Roger, you're loud and clear here also.
Space Nuts.
This is Space Nuts with Andrew Dunkley and Jonti Horner. Our next question comes from Doug. It's an audio question.
Hi, Space Nuts. It's Doug and Hazel, the Wonderdoodle, calling again. Thank you for your responses to my previous questions. My question this time is about blocking sunlight. Given that we, as humanity, have no ability to control our carbon emissions, it seems the next question is, to me, is geoengineering possible? Now, given that seeding the higher atmosphere with reflective particles would probably not go over too well with the chemtrails people, I'm going to suggest that putting some sort of sun blocker out at Lagrange point 1 would be a solution that would probably need to be investigated. ChatGPT suggested that a 3 million square meter parasol, for lack of a better word, would block 1% of the sun's light hitting the Earth. Don't know what the magic number is. Don't know if we should even do this. But the question I have is, does anybody know about anybody working on this particular program right now as a contingency? Thanks very much. Have a good day.
You too, Doug. Thank you. And hello to Hazel the Wonder Doodle. This has come up before, and I do think somebody has been looking into the possibility of putting a parasol in space to try and shade Earth. I just don't know how well it would work.
No, it's a challenge. I mean, the reason I'm chuckling a little bit in the background here is not actually about this idea, which I think is a good one.
It's Hazel the Wonder Doodle, isn't it? That's what's making you chuckle.
It's not even Hazel the Wonder Doodle. It just amuses me that on the one hand, we're talking here about building parasols to shield the sun from the daytime sky, while at the same time, a few weeks ago, we talked about a group of idiots with a startup in California to reflect the sun to shine it on the nighttime sky. Yeah. And I've got visions of the fact that you get these wonderful geoengineers deliberately blocking sunlight from the daylight sky, only to have their work undone by a group of equally stupid people shining lights on the nighttime sky to just basically make the nights hotter and offset all of the good work. But that's more me chuckling at the idiocy of Reflect Orbital than it is about this question, because this is actually a really good question, Doug. It is abundantly clear that, so okay, don't mind me, I just got a weird pop-up saying I'm going to expire after 150 minutes of inactivity, which is never good, but I don't think that's to do with space nuts, so I've just moved my mouse and all is good. So I am not going to expire live on air. This is good. Yeah, so there is fundamentally an issue that the planet is warming, and the planet is warming because of human activities, and that is not open for dispute really anymore. I know that there are a variety of opinions available on this, but for me as an astronomer, the evidence is utterly overwhelming. And the only thing that can explain the changes that we're seeing, not the size of the changes, but the speed of the changes, is human activity. No physical process other than perhaps a rock hitting the Earth and killing everybody, like the dinosaur level extinction. There is nothing else that could cause this rate of change. So it's very, very clear that human activity is the cause of this, and that there is some inertia in trying to persuade humans to stop doing the things that cause the problems, and I understand that. So there's a growing list of suggestions of ways that we could mitigate for climate change out there. One, as Doug said, is sprinkling reflective particles into the upper atmosphere to effectively increase the Earth's albedo, which would mean more energy was reflected to space and less makes it down to the surface of the Earth to kind of heat the pressure cooker. And that could possibly work. It'll be interesting to see what role SpaceX plays in that in the years to come, because with all of the satellites they're launching, there's a growing number of things returning to Earth and burning up in the upper atmosphere that are depositing metals like aluminium into the upper atmosphere, and nobody's really sure what's going to happen there. So that might actually inadvertently do exactly what Doug mentioned and increase the Earth's albedo and offset some climate change, or it might make it worse. People are still trying to figure out what's going to happen there. And that ties into the idea that space is still a little bit of the wild, wild west, in that things are happening faster than legislation can adapt. You know, we've got tons of aluminium being added to the atmosphere and we don't know what it's going to do. But that might have part of this effect. But an obvious way that you could cool the Earth is by blocking some sunlight. Fundamentally, that makes sense. If you block 1% of the sun's light, you block 1% of the energy coming into the Earth, which will be about 13.6 watts. The solar constant's about 1360 watts per square meter. Block 1% of that, that will be 13.6 watts, and that will be more than enough to offset climate change, and probably more so. But let's say we wanted to block 1% of the light from the sun. That means you would need a parasol that is equal to 1% of the cross-section of the Earth, if that parasol blocked all of the light from the sun that was hitting it. So that means 1% of the Earth's surface would be dark, the sun wouldn't be falling on it. Or you diffuse that and you have 1% less light coming down. So if you do the maths of that, the Earth has a radius of about 6,378 kilometers. That varies because the Earth's a bit oblate, so the radius from pole to pole is different to the radius from across the equator, but we can use that as a mean radius. That means that the Earth has a surface area of about 1.9, I think it was, times 10 to the 14 meters squared. So to block 1% of the light, you would need a parasol that is 1% of that. So that would be about 1.28 times 10 to the 12 meters squared, which means that you would need a parasol I'm sorry, kilometers squared. I've done this calculation in kilometers, which would, no, that is in meters, sorry, which would mean you'd need a parasol, if you made it square, that is 1,130 kilometers on a side. That, I think, is technologically beyond us at the minute. Added to which, you know that the politicians would want us to mine that material on Earth and launch it because that would be more profitable. So the process of mining and launching all that material to build 1,000 kilometers on each side parasol will probably put far more greenhouse gases into the atmosphere and exacerbate the problem. The other challenge you'd have with the parasol issue, though, is that the L1 point, which would be the obvious place to put it, that's a point between the Earth and the Sun where an object would rotate at the same orbital period as the Earth and be in this kind of semi-stable location. That's where a lot of our solar observation spacecraft go, like SOHO, to give us early warning of space weather. Now, the L1 point is about 1.5 million kilometers away. Things at L1 are not fully stable, so they need rockets and actuators to keep them on point, because if they drift too far away, they'll fall out of the stable area and go off orbiting the Sun on their own. So what you need to do is have an object 1,000 kilometers on each side, located 1.5 million kilometers away, that could be positioned accurately enough that the shadow it casts hits a target 6,300 kilometers in radius, rather than missing us. So as it drifts around, we'd have to keep it on point to an accuracy of just a few hundred kilometers. And so this is one of those things where it's a fabulous idea for science fiction, and it is the kind of thing where we can imagine all of the steps we need to take to make it work. So it's within the bounds of our technology in terms of our ability to make stuff, but it's the scale of it that makes it impractical. And that's why a lot of these ideas of parasols fall down, is that the amount of area you'd have to cover to block enough light to make it feasible are so huge that it's just technologically the building of them and the keeping them on point will be too much of a challenge. It'd be a global endeavor that would make the efforts for the Apollo missions seem like tiny little small fry in comparison.
Yeah.
I don't know if anybody's ever done a calculation of the cost that this would have, but I suspect there are other geoengineering ideas that would be more financially feasible. I'm always an optimist. I mean, I am very worried, like everybody is, about climate change. I have been since I was a kid. I've lived in places where it is writ large on the landscape. I always talk about when I lived in Switzerland, and they've got photographs from midsummer in all these little alpine villages of the glacier just behind the village even in midsummer. And then you step outside and you can't see the glacier because it's retreated so far up the mountains it's no longer in view.
Yeah.
So I've lived in places where it's obvious, but I'm always of the idea that eventually human ingenuity and commercial interests will get to the point where it is something we'll solve. And I think we're seeing that a bit now with electric cars. You know, we've had the technology to have electric vehicles for more than 100 years. I remember getting milk delivered by the milkman as a kid, and they were going around in electric milk carts, you know, so we have that technology even then. But for a long time, nobody's had electric cars, nobody's considered it solvable, but eventually the costs have dropped enough that they're a viable alternative, and now people are taking them up. So you're seeing a drop in the number of petrol vehicles. And I'd like to think that because a lot of the things that we do to cause climate change are fundamentally inefficient, as our technology improves, we'll move to much more efficient processes that generate less of the things that cause climate change. And we will find a solution. But the problem is the lag time is such that the longer we wait, the worse it's going to get before it gets better again. Yeah. And there are some suggestions that, for example, the horrendous hurricane that hit Jamaica last week was significantly worse because of the effect of climate change on the temperatures of the water. There's now actually a whole branch of mathematical science that delves into calculating not a yes-no, did climate change cause this event, but rather a statistical analysis of how much worse was this event as a result of the effects of climate change. And I think the numbers for that hurricane last week were quite startling, that it was made noticeably worse because of the increased heating of the ocean and all the rest of it.
Yeah,
it is a real problem. We want to get solutions, but I think the parasol is a bit too hard.
Yeah, I did read the science behind why that storm was so severe, and it was quite an interesting read, and I won't go into it now because I probably get half of it wrong. But you might also be interested, Doug, to know that there have been some researchers looking into this, not just maybe a single object in space to block the sun. But University of Arizona was looking at a cloud of small spacecraft. There was another research effort at MIT looking at inflatable space bubbles. Another idea out of the University of Hawaii, tethering shades to an asteroid, the asteroid being used as a counterweight if they could capture one. That's another impossible dream at the moment. Solar sails and lightweight films, and even one proposed only a couple of years ago was to start ejecting lunar dust into space to create a dust cloud to block the sun. My worry is if we do decide that that's the solution and we do it, and then we solve the problem of global warming, won't we then put ourselves in a position where we could cause a global winter? It's even if we reach a point where we've got the technology to solve the problem, as Doug said, should we do it? And
we also come to really interesting questions, because underlying the climate change we've got, there's also the fact that the Earth's climate changes naturally on much longer timescales. We get the glacial and interglacial periods. So if we ever do get to the point where we've got climate control, so in other words, we can set the Earth's climate to be at a certain point, we can fix a problem. And if we can fix a problem, we can then say where we want the climate to sit. What do we choose? Do we allow that very slow pace of climate change to happen? Do we figure out the conditions that are optimal and set it there? There's a lot of really interesting stuff that would feed into science fiction rather than science fact that come from the fact that if you've got to the point where you can solve the problem, you've got to the point where you can geoengineer the Earth's climate to suit. So where do you therefore set the sweet spot? Do you set it at the year 2000 mean, the 1900 mean? Do you make it a little bit cooler than that? Do you make it a little bit warmer than that? It's a really interesting one, which for an incredibly complex and chaotic system would lead to a lot of implications about weather disasters and all the rest of it. Yeah, there's a lot of interesting stuff there. I think it's going to be interesting times for the next 100 or 200 years as humanity tries to solve the problems it's made.
Indeed. Yes. Thank you, Doug. Great to hear from you. Keep them coming. There's some terrific ideas out there that people want to learn more about. And this is Space Nuts with Andrew Dunkley and Jonti Horner.
0G, and I feel fine.
Space Nuts.
Our next question comes from another YouTuber. And the question is, who has the salvage rights on all the scrap satellites? And is there a plan or a map of all the defunct scrap in orbit? Possibly in the future, there would be good business in recovering all the precious metals, etc. It's a good question. I know they were experimenting with different ways of bringing down defunct satellites. And all they were doing was like testing harpoons and things like that, or whatever, to make them re-enter and burn up. But this is a whole new ball game, salvage. I haven't heard of it. Have you?
It's yet another area where legislation is not keeping up with use. So there's a lot of challenges with this. Space is vastly big, and the things we put up there are very small compared to the size of the space that's up there. There are a lot of efforts going on to map and to keep track of all of the bits of debris, both large-scale like satellites and former rocket bodies, down to the very small fragments you've got out there. And that's the whole area of space situational awareness. There's telescopes around the world tracking debris, keeping it in databases. And the thing there is that you can't just assume that once you've seen it, you know what its orbit is and you'll know where it is forevermore, because it's a complex environment where the Earth's atmosphere is breathing in and out, getting bigger and smaller, and the solar wind is varying, and all these things that happen, even down to the subtleties of the varying densities of different parts of the Earth's surface causing slight changes in the Earth's gravity. At the kind of level you want to track these things, all of that means that you need to keep tracking them. You can't just find them once and say it's there and that's it. So there's a whole burgeoning kind of research industry built around tracking this debris, using laser range finding to get as accurate a position as possible. And part of the reason for that is so that things like expensive satellites and the space station can dodge when there's a chance of an impact. That's always helpful. It is also just so that we are aware of what's up there, and it's a problem that's only going to get worse. Now, I did a little bit of searching around because I had never thought of the salvage of satellites and stuff like that as being a thing. Now, in maritime law, there's this concept of the right to salvage, which is when something is becoming dangerous or when it's out of control, which allows people to claim salvage rights.
Yeah.
There is no such thing in space. I found a few articles that all confirm that, and I quote from an article in the spacereview.com, there is no right of salvage analogous to the right found in maritime law, which means that even though a satellite or some other space object may not be functioning, that does not imply that it has been abandoned by the nation that launched it. And there's a pretty lengthy spiel following that, which basically says if you don't have consent from the nation that launched and operated that thing, you're not allowed to dispose of it or interfere with it.
In fact, I might just add a caveat to that. If you launch something into space, it is your responsibility.
Yes, absolutely. Which follows on to the next point. That's the issue about salvaging it while it is still in space. And I could imagine that with sufficiently future technology and a more crowded environment around space, there could be a commercial opportunity for somebody to develop a cleanup crew, which companies who own a satellite can pay to recover their satellite and dispose of it safely, or to give harvesting rights or whatever, where that's dealt with. I could see that as a commercial thing down the line. But it also has an impact on what happens when satellites fall back to Earth. Should they make it through the Earth's atmosphere intact and make it to the surface of the Earth, as we saw with Skylab in Australia in 1973, for example, and more recently with fragments of SpaceX debris littering the planet, you might think that if it falls in your backyard, it's yours, but it isn't. The ownership remains with the people or the country that launched it. And so back when Skylab landed in Western Australia, the area in Western Australia where it landed cheekily sent NASA a littering notice and a fine, which got paid, which was quite good fun. A few years ago, when large pieces of a SpaceX rocket landed in the Snowy Mountains in Australia, people were advised not to pick the bits up and collect them, but to let the Australian Space Agency know. Because technically, the Space Agency has a whole plan, and this is laid out on the Space Agency website under space.gov.au/discovery-of-space-debris-in-Australia. So space.gov.au/discovery of space debris in Australia details the regulatory side of things and what the Space Agency does, and says the Australian government has plans in place for events where space debris impacts Australia. Description of what it is and what the role is, and it lays out the steps that if you find space debris in your backyard, you should follow. Step 1 is do not touch it, and I cannot stress this enough, do not touch it. Space objects are built from materials that can be hazardous. This is exacerbated by coming back through the atmosphere and getting damaged. So it says space debris should only be handled by appropriately trained and equipped professionals. That was particularly relevant with the fragments of the SpaceX rocket that fell near the Turks and Caicos Islands earlier this year, because there was a whole brouhaha about the cleanup, and SpaceX was not following its requirements and not doing much, and people were upset, and some people have been going and collecting bits of debris, and there was a risk they'd fall ill and stuff like this. So step 1, don't touch it. Step 2, contact your local authorities. So if the situation is urgent, contact 000. So I guess that's if a piece of a SpaceX satellite hits your Tesla. Don't contact the museum, call the police, fair enough. Otherwise, call the police assistant line. So you get some advice, and then you notify the Space Agency. And what the Space Agency then has to do is figure out whose bit of debris it is, get in touch with them and liaise with them, because there is a requirement for us to return the material to them. It is their property. And so from salvaging here on Earth, you don't have those salvage laws, because even if it's a burnt up fragment of rocket, it's still property of SpaceX, or it's still property of the Chinese government. And so we don't have that kind of salvage setup at the minute. There's a description of what happens once debris is identified as space debris, and it says, if an item is confirmed as space debris, the Australian government has international obligations to notify the launching authority of the discovery, and upon request may be required to return the debris. So you can't salvage it. Now, this may become something where the laws evolve in the years to come. As I say all the time, our use of space is still in this Wild West phase where our ability to do stuff is growing much more rapidly than our ability to legislate for it. And there's a lot of commercial interest in not advancing the legislation, because if you advance the legislation, you put more costs on the commercial entities. So they have a vested interest in not having legislation about launches, not legislating for the number you can make or the environmental requirements. And countries are leery of doing it because you can launch to space from all over the globe. So if you say to SpaceX, you need to meet all these punishing environmental conditions before you launch, and you've got to do all this with your satellites, SpaceX can easily say, well, that's fine, we'll take our investment and move it to another country. So there's a lot of challenges there, but I could imagine in decades to come, as commercial space becomes more established and our use of space becomes much more varied and much more numerous, astronomers will complain because you get more and more spoiling of the night sky. But you'll also get the opportunity for businesses, just like this question describes, to develop, why there may be the commercial value for people to recover defunct satellites in orbit, capture them, maybe even lift them up to a higher orbit to a factory that can process the materials, and let people then build new satellites in orbit. That way, you lower the risk of them burning up in Earth's atmosphere, you get rid of the possibility of them altering the atmosphere to make climate change worse or better, as we discussed before. And you lower the cost of launching new ones if you could reprocess and salvage and rebuild.
Yeah.
It's probably not commercially feasible yet, which is why nobody's doing it yet. But it may well become so. And so this is something that I'd expect to evolve in the next, say, 50 years as all this stuff becomes more entrenched.
It's interesting in regard to the ownership side of things. It's like when you put your garbage bin out with all your stuff in it, it's still your stuff. And even as far as it being dumped in landfill, if you've thrown out your son's favourite toy and he wants it back, it's still his toy. So it's the same kind of thing in a down-to-earth kind of way. And to our YouTube listener, just one final point. Yes, there are companies researching salvage in space. Newman Space, another one called Astroscale, and of course the major parties, NASA and ESA and several others, are looking into this. But right now it's not a very easy thing to do. But thanks for the question. Really good.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
We have one final question. This one comes from Robert, and Robert is from the Netherlands, and he's got backing music on his question.
Hello, this is Robert from the Netherlands. I have a question for you today about radio waves, because, as we all know, it's a very efficient, low-energy way of communicating data over vast distances. And I would think that if we are looking for aliens, which I find very tantalizing at the subject, we should be looking for radio waves, probably like 500 light years of a radius of the Earth, which seems to be kind of a low priority. Never understood why. There's a beanbag observatory that can really pinpoint these things, but it can't really cast a wide net, so to speak. The square kilometer array might be capable of this. It's being built in Australia, of course. I was hoping you guys would have some insights. They're going to be looking for radio waves. Thank you so much. Take time.
Thank you, Robert. Lovely music. Yeah, very, very spacey indeed. I would have thought that that's prime target number one when searching for life beyond Earth would be to be listening for radio waves. And Robert's right, the square kilometre array will be capable for that. I think it'd be able to pick up airport radar as far away as 50 light years.
Yes, it's an incredible tool. And in fact, this is what people have been doing. So this is the whole foundation of a subset of our science called SETI, the Search for Extraterrestrial Intelligence. Often you describe this as a search for a needle in a haystack where you don't know what a needle looks like and you've never seen a haystack before. So if you're trying to find life that is as technologically advanced as us or more so, then there is an argument that listening for signals would be a good way to do it. And kind of corroborating that is the idea that we are broadcasting into the void, screaming like a toddler in a dark cave, with our radio broadcasts and our TV broadcasts and all this stuff with radio waves. And it's often argued that either the Berlin Olympics, which I think were 1936, or the coronation of Queen Elizabeth II in possibly 1952, 1953, were the first broadcasts that were powerful enough that would be easily detected from elsewhere. So if you were magically able to take the square kilometre array and place it as a star within about 80 light years of the Earth, you'd be able to listen in and watch the development of our technological society as our broadcasts get more numerous and more varied. You'd probably be able to broadcast back and say, please stop broadcasting, neighbours, we're sick of it. We want to know more about Scott and Charlene or whatever. People will be able to listen in. And so this gives everybody the idea that just like this question, we could do the same thing and we could try and tune in onto the broadcasts of other societies. And that's fundamentally the foundation of SETI. Back when I was an undergraduate, back when I was at high school, in the early days of personal computing, there was a program called SETI at Home, which was a way of distributing through cloud computing packets of data obtained by radio telescopes to search for signals of radio broadcasts, and nothing was found. There are global usage of radio telescopes around the world to try and do this still. The most famous of them these days is the Breakthrough Listen initiative, which was funded to the tune of $100 million starting back in 2015. So it's 10 years old now. That did a wonderful thing for Australia because the government at the time in Australia was our less science-friendly party, let's put it that way. And they were looking to save money by killing science, as often happens, and that's having knock-on effects nowadays. But one of the things they wanted to do was close the dish, the Parkes Radio Observatory, which is the biggest, most iconic observatory building, I think, in Australia, famous for the awesome movie The Dish with Sam Neill many years ago.
And it's just down the road from where I live.
Just down the road. And there was a lot of upset that this wonderful facility was going to be mothballed and closed down to cut budgets. Because, you know, they wanted to put more money into fossil fuel extraction to satisfy their donors or whatever. I have views. But anyway.
Many do.
Parkes was saved by an injection of a very large sum of money from the Breakthrough Listen initiative, which has kept the telescope operating for another decade. There's a lot of awesome new science has come out of it as a result. But it has bought a certain fraction of the time on that telescope, which I think is about 40%, to specifically point that telescope around the star to listen to radio broadcasts, to look for radio broadcasts from nearby stars. And there's been a number of papers come out on this over the years that detail the incredible work people have done. And to illustrate the challenge of these things, there's been a few occasions where people think there's been a potential signal, only for it to be turned out to be something else. One example was that they thought they'd found a potential signal, and when they investigated more, it happened at the same time every evening, and investigated more, and it was that the astronomers were walking across one of the building and putting their food in the microwave.
Yes.
Although the building was shielded, they were picking up the radiation from the microwaves. You know, so it's really hard to do. To date, we have found nothing.
No.
And there are some arguments that it's very unlikely we will do. That's a needle in a haystack thing. Firstly, we need to figure out where in the radio spectrum to look. And the radio wave frequency spectrum spans an enormous range. A lot of efforts have been focused around the hydrogen 21 centimeter line, viewing that as being an obvious place for people who are deliberately broadcasting to broadcast because everyone will know about that. But in terms of accidental broadcasts like what we're doing on the Earth, there's no guarantee that another species would pick the same frequencies that we've chosen for the broadcast. So we might be listening to the wrong tune. We might just be listening at the wrong frequency. The other thing, though, is that the kind of broadcasting we've been doing for the last 100 years is incredibly energy inefficient because we broadcast in all directions at once to have a very small number of directions pick up that signal, you know, all your TV aerials or whatever. It is much more efficient to do point-to-point communications or to send things through optical cables. So there is some argument that as your technology gets better, the amount of waste noise you broadcast to space will fall off.
Yes.
And so there's an argument that in the next 30 or 40 years, the Earth will become radio silent again. So then there'll be this little bubble around the Earth getting bigger and bigger, where if you're in that bubble, you hear our radio broadcast, but then there's a smaller bubble in the middle where we go silent again.
Yep.
And it may be that every technological species is only loud when it's in its infancy, when it is that toddler screaming that they don't want to leave the beach like the kid I saw yesterday. And eventually a society learns to self-regulate and has more efficient ways of broadcasting. So it is a fabulous question. If you want to learn more about it, I do recommend looking up and Googling and reading around SETI as a project, SETI at Home, and the Breakthrough Listen initiative. You can also look up an associated thing, which is METI, M-E-T-E, which is, I think METE is the acronym, which is a search for the artifacts of advanced civilizations.
Oh.
And I know colleague of mine in the US who's part of our planet search team has put out a few papers looking at things that appear in science fiction like Dyson spheres and ring worlds and what effect they would have on the light from their stars. So what the observational signatures would be, not with any expectation that we'll ever find them, but because if we don't model what they would be like, if we ever see something that displays that odd behavior, we wouldn't know what it was. So it's, again, this very low likelihood of finding something, but very high reward if you ever do, I guess, that people are actually actively thinking about. What could we feasibly do as a technological civilization in the future with improving technology? How would that affect our environment around the sun? How would that affect the way that our planetary system appears from around other stars? And what would that look like if we saw a different civilization doing it? So that we have the predictions there, so that when we get vast amounts of data from these all-sky surveys, whether they be in the radio or whether they be in the optical, we can identify the oddities and figure out what they are. And similarly with the Square Kilometre Array, that will be pointing all over the sky doing lots of astronomy. But the data from that will be analysed by teams who are interested in could there be an alien signal buried in this. So you will get serendipitous imaging there because wherever it's looking, you get the data and you can survey that to see what there is. So it is something people are actively doing. You're onto something good there. And I can recommend, like I say, reading about Breakthroughless and reading about SETI to learn more about it if that is what you're interested in.
Yeah. It'd be interesting to discover another race somewhere out there that's built a megastructure like, I don't know, a space parasol array of some kind. Imagine that. Same problem. Someone else has solved it. Yeah.
We are going to be doing a little baby test of that potentially in the next 10 or 20 years if NASA ever gets its funding back. There is the Habitable Worlds Observatory that is looking at planets around other stars. And what they're proposing to do to allow them to gather light from planets the size of the Earth around stars like the Sun is reflectively fly a very giant, beautifully designed, very intricate, fractally edged space parasol that would go out about 100,000 kilometers from the telescope and fly in formation and line up to block the light from stars so that we can see the planets going around them. Oh. Now, that size of parasol would be way too small to impact climate change.
Yeah.
But it's a really good tech demonstrator. It shows that we can do that and we can get the station keeping, just much too small. And again, if people are interested in that, looking up the Habitable Worlds Observatory would be a good place to look. And there's some lovely videos of the animation of this thing being launched and unfolding and moving out into space. And they've even done tests in labs for mini versions of it on long corridors to prove the concept works. All very cool.
Very cool indeed. And a cool question too, Robert. Thanks for sending it in. And if you would like to send us questions, don't forget our website, spacenutspodcast.com, spacenuts.io, and click on the AMA link and you can send us text and audio questions through that system. And we'd be happy to get them and we'll do our very best to answer them. Sometimes we get the same questions, which is not unusual if people sort of hone in on a topic. So we'll if we don't answer your question, it's possibly because we've already done it. But we do redo questions from time to time because they keep coming up, particularly black hole questions. We quite often get a repeat, might be a couple of years later, but we get a repeat of a question we've already covered. So we'll sometimes redo them. But good to hear from you, Robert. Thanks to everyone who contributed. And thanks to you, Jonti, for having a crack at the answers.
That's all good. It's what I'm here for. It's fun to face new and interesting questions.
It is indeed. We'll see you on the next episode. Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. And thanks to Hugh in the studio. Not sure you're aware that Hugh used to work in radio. That's how we actually met. In fact, he was working at a radio station in Newcastle in New South Wales when I was a kid, and I did job experience there. And that's how I met Hugh originally when I was about 13 years old or something. Anyway, he's an old radio man these days. And when it comes to radio waves, he feels that means he should stand out the front waving at traffic That's why he's not with us today. And he may never come back. And from me, Andrew Dunkley, thanks for your company. I'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.